On question number 3 says the orange function shows the extreme temperatures both in cold and hot and the electricity usage rates. The blue shows the extreme temperatures, the production. So pretty much answered that in question number 2, didn't I? Now on question number 4, using the graph, we look for the temperature at which the models intersect. The intersection appears to be on the right at 45 degrees and 105. So at 45, under 45 and above 105, the usage begins to surpass production. Now on question number 5, notice I don't want you to use a graph here. I want you to use algebra. I want you to find the production at 80 degrees. Well, if we go back here, remember production was negative 0.5 times x. Well, in this case, it's 80. Minus 75. And then we're going to add, I think it was 90 if I remember right. Plus 90. Okay, so let's find that. 80 minus 75 is 5. And then the absolute value of 5 is 5. And so we get negative 2.5 plus 90, which would be 87.5. Now, I will do usage in red. In usage is going to be negative, not negative, take that back, positive 0.5 times, would be say 80 minus 75. And I do believe it was plus 60, wasn't it? Yeah, plus 60. So 0.5 times the absolute value of 5, which is 5. I don't know why I put a negative in there again. My brain just 0.5 times 5 plus 60. So I get 2.5 plus 60, which is 62.5. And then to find the production, I subtract those two. Or my surplus, I should say. I already did the production. So my surplus is going to equal to 87.5 minus 62.5, which gives us 25. On question number 4, or 6, I'm sorry, we're going to solve this equation. Remember, to solve an absolute value equation, you've got to get the absolute value by itself first. So the first thing I'm going to do, I'm going to subtract 4 from both sides. So we get the absolute value of negative 3 times the absolute value of q equals 6. Now we'll divide both sides by negative 3. And we get the absolute value of q equals negative 2. However, absolute value cannot be negative, so therefore there should be no solution. You can't tell there's no solution without showing your work. You need to show your work on this problem. Okay, let's take a look at number 7. Kind of the same way. I put the answer up top, so made it kind of hard to show our work on this video, but we'll do our best. First thing we're going to do, once again, I want to get the absolute value by itself first, so I'm going to subtract 12 from both sides. So if I subtract 12 from both sides, we get 4 over the absolute value of p equals 14 minus 12 is 2. Now you got a problem. P, the absolute value of p is in the denominator, isn't it? There's two ways to do this. One is we could multiply both sides by the absolute value of p, so you get rid of that. The other way to think about it is, hey, I just want it in the numerator. So what I'm going to do, first I'm going to change 2 to a fraction, put it as 2 over 1. And then what I'm going to do is I'm going to take the reciprocal of both sides. The reciprocal of both sides means I'm going to write it as absolute value of p over 4. That gets p in the numerator equals 1 over 2. Whatever I do to one side, I got to do the other. So if I take the reciprocal of the left side, got to take the reciprocal of the right side. Then we multiply both sides by 4. We get the absolute value of p equals 2, because 2 goes into 4 2 times. Now, since the absolute value by itself, now you make your two cases. You say, oh, p equals 2 or p equals negative 2. And that's where, in the answer, I said p equals plus or minus 2. So a positive or negative 2. To graph it, we make our number line, and we just put a dot on each of our solutions. And there's your answer.